system and how it works all together and what it looks like. Then we'll go into a little bit of programming. Acrobat and Android Studio, those are the two programming tools that we have this year. And then we'll just do a couple of tips that we have in Noisebox. And then we'll have time for questions, so just save your questions for the end if you have any. Okay, so the new platform. What's changing? We don't have an FTC anymore, which is a pretty big deal, and also no Samantha module. We're using the Android VTE phone on the robot as well. And we're using Wi-Fi Direct this year, so no FCS. All data connections are now USB, which is also going to be good and faster. No robot CR Lab View. We're going to be using Java. And with Android Studio or with App Inventor, it's really your choice. We'll talk about that a little later. So competitions are also going to be different. We're going to have no software inspections, which is going to make everything a lot quicker. No FCS, so it's a sports start. 3, 2, 1, go. You press a button on your phone and off, autonomous. So yeah. So the power distribution module, it looks like this. It's basically the only thing that's going to connect directly to your phone. It distributes the power. It connects to the 12-volt battery. We actually recommend changing the 12-volt battery connector to Anderson power pole just because it'd be easier since you're using power poles for everything else on your robot. As you can see, the outputs for the motors and servo controllers are Anderson power pole. The motor controller module is also Anderson power pole. You're not allowed, or you're not really capable to daisy chain this year, so that might be a little different, not what you're used to. It has a super durable mounting bracket, which is a lot better than last year. Sometimes we had issues with that. And it has 2 motor encoder connectors. So. The servo controller module controls servos. Also Anderson powerful connectors, can't daisy chain, and you got the durable bracket, and you can connect up to 6 servo motors, which is awesome. The device interface module. You might have heard of this as the advanced sensor module. That's what they refer to it in the FTC videos going over the new stuff. They refer to it as the advanced sensor module. So there's a lot of confusion about like what's it called. But it's got a lot of ports. You can connect so many different sensors. If you wanted to use a sensor last year that was like off the shelf, you kind of had to use a proto board, which was really complicated. But this year you can just use this. So it's awesome. The core legacy module, this actually doesn't have a direct power input. We use this if you want to use the old motor controllers, servo controllers, or the sensors. So this is for teams that want to use all those old sensors, but you can also use this for new sensors as well. So this will be really helpful for you if you're using anything from last year. So putting it all together with the legacy module. As you can see here, this is the USB, power and data, all these lines. It starts with your phone. There's no NXT or Samantha. It goes from your phone to the power module, where you then connect your legacy module and all your sensors. And it also connects to your motor controllers if you're using your old motor controllers, which can connect to the motors that we have. If you're using the entire new system, this is what it will look like. We have the ZTE, and then it goes to the power module. You have your batteries, but it goes directly to your motor controllers and servo controllers. Your legacy module you can use with that as well if you're using a whole system. You don't have to use your old motor controllers if you're using a legacy module. You can also just use it for sensors. And then you have your advanced sensor module up there. So programming the legacy module. This is where we're going to talk about programming a little bit. So, user interface for the app inventor runs on Chrome or Firefox. Full instructions and basic use are available from Intel's at the URL up there. And also help on this group, Google group. That's actually where we found the best information for this stuff. There's not too much information yet, but that's a really good group that you can use up there. So it's a drag and drop component and block-based programming environment. So components are visual representations of physical hardware devices like motors and sensors, and then blocks are representations of logical programming, like if, then, and while loops. So first you select your components on the screen, and then you build your program with blocks. So it's pretty easy to learn, and it can be used without internet access if you just follow the installation instructions from Inteltech. So most of the FTC hardware components are listed on the left plane. You select one, and you drag it to the viewer, and then you set the property values for each component over there. Visual components are displayed on the screen plane, while non-visual components, so this is the screen plane, non-visual components will be popped down here. So, like motors, you can't see that on the screen, so it'll be down there. You can see it more once you actually do it. So some interesting components currently available in the SDK for App Inventor. In early releases of SDK, some functionality was only available through FTC DC motor controller component and not through the FTC DC motor controller. Motor component. But in the latest release, FTC motor controller only is needed if you want motor encoder information. So that's one thing to know. There's a lot here. Okay, so general overview of what you need to build a simple program in App Inventor. The FTC robot controller component establishes communication with the driver station and then loads the robot configuration file. So be sure to enter the same config file name in the configuration. Where is that? I don't know where it is. Configuration field, and then enter where you set up the hardware config on your robot controller. So you can see that we named it LazyBot up here on the configuration. So that's where it is up there. So you need FTC op mode component for each op mode in your app. So we named this op mode teleop, and you probably all know what that is. It's really just a fancy word for a program, and you name it here, and that's how you're going to see it on the driver station on your phone. So for this demo, I named it teleop. Note that you do not need to create a new project for each op mode. You can add several to one project and then select which one you want to run from the driver station. So to control the motors, you add FTC DC motor components right here. When you set up the hardware configuration on the robot controller phone, you have to name these the same as the device name field over there. You have to name it the same thing, otherwise it's really confusing. So it's the device. I set the device name and the component name to the same thing to make it easier to understand. So right motor and left motor. So you can see that. Okay, so once you've added the components, App Inventor will look somewhat like this. You can see here's the non-visible components and the visible components. So the non-visual components, FTC op mode, DC motor, gamepad, are shown down there, and the components you can see are on the screen you were playing. So the next step is to switch to the block view up there on the right corner. And well, this is what it looks like when I was on Google Chrome. The current version of Google Chrome actually doesn't work with App Inventor, so at this point I switched to Firefox. That's something to know. Firefox, it does work, and it should look like this. So this is what's supposed to be displayed. As you can see, there are logic and variable blocks as well as blocks for each component that you added. So when you select a block, the viewer will display all the options available for the block. So you select a block, shows what's available, over there in the viewer plane. So when you click on the block options, the rest of them will disappear, then you drop the block into the viewer plane. So each programming block is kind of like a puzzle piece, and the matching connectors on the components can be connected. So this is kind of what it'll look like. The sequence is basically like a do loop in Roxy. So while the teleop mode is running, you set, this is kind of what's happening right now. It says while the teleop mode is running, the right motor direction is in reverse, like we used to do in the motor config in Roxy. And then set the DGT power variable equal to the negative value of the right joystick on keypad 1. That's what it looks like. And then you set the power level of the right motor to the value of DGT power variable. I'm going to toss it over to Chad, and he's going to enlighten you on Android.
Thanks, Rachel. All right. First of all, how many people think they're going to be programming in Java this year? Fair amount. And how many people in this room have actually downloaded and installed Android Studio? And a better question, how many have not done anything yet but are planning on using Java? Okay. So it sounds like a fair amount of the room is going to be using Java, and a fair amount of the room has done something already. So the slides that we prepared kind of assume most things are kind of set up and working. Android Studio is installed. You've gotten the latest software off of GitHub. I am expecting a new SDK release pretty soon. They still don't have the final SDK out, so I would expect that here pretty soon. So some things like you're going to have problems with Matrix because the Matrix controllers aren't supported yet in the Android SDK. I don't know that they're supported under App Inventor either. But the legacy module with high-technic controllers does work. So I'm kind of assuming that you've downloaded the code, you've got it running, you've installed the driver station, you've connected your phones to Android Studio, you can compile and download a robot controller app, you've named and paired your phones. I mean, there's a lot of little steps, but once you kind of get them all working once, then actually the developing and connecting to your robot is pretty easy. My suggestion, if you're on Android, because of the way that the phone needs to be connected to something, the device in the core power module, you really can't connect to it to program effectively. So everybody will probably, the very first thing that we do when we're programming is get a wireless debugging mode. So this slide just kind of goes through, the phone will be on Wi-Fi Direct and on your access point at the same time. This is for development. At an event, you'll only have Wi-Fi Direct. There won't be any access points. But at home, you can go ahead and connect your robot controller to your home network, your school network, wherever you're at. It'll also be Wi-Fi Direct connected to your phone to the driver station at the same time. So if you're going to need the IP address, which is just what this screen is showing, you can get through the settings. Once you know your IP address, making a Wi-Fi debugging connection is pretty easy. Inside of Android Studio, at the very kind of bottom of the screen, there'll be this, this is the tab where when you actually connect your phone up by USB, it'll tell you your connection. Click on Terminal, and you have to type in two commands. ADB TCP555, that's going to be what port you want, and you're telling the phone to go into an ADB wireless debugging mode. Unless the phone is rooted, it won't stay in that mode. And right now, we really don't have root ROMs and stuff, so everyone's working with unrooted phones. I don't think it's a rule, but I don't think we have good ROMs to work with for rooting the phones. So you have to do this basically every time. You kind of turn the phone on. First thing you do, connect it up to your computer on the USB. You run that command, and after that, you can actually disconnect it. And then the second command is where you need your IP address, ADB connect, the name of the IP address, and then the port that you use for the TCP debugging port. Once you've done that, then you can remove the USB cable, put it on the robot, plug it into the robot controller, and now everything you do from inside of Android Studio will connect over your local access point network, not the Wi-Fi Direct network, to the phone. What we're going to do in events, I'm not entirely certain yet. There are ways, although we haven't got it working yet, of connecting over Wi-Fi Direct on the PC side. Possibly if you do Bluetooth, TCP over Bluetooth, or you just have to make a change to your plug it in, make a change, unplug it, plug it into the robot. So developing at events will probably be a lot more difficult than it has been in the past, but running at the event is a lot easier than it has been in the past. So kind of get a good trade-off there. And I'm going to kind of go through this quickly because we're kind of running out of time. One of the most important things for really the legacy module versus the regular is all in configuration. Once you have your robot configured, there is no difference in programming between the legacy module and the new modules. There's some small things with timing and when you're trying to read values, but if you're just writing the motor values, it's pretty much the same. So you have to have a configuration file on the robot that connects up to the exact hardware, the exact USB hardware that is on that robot. If you change on a motor controller, you're going to need to change your configuration. If you move your phone that is the robot controller from one robot, test robot, to maybe your other one, you'll need to change your configuration. The nice thing is the configuration file is the only thing you have to change. So there's instructions out there on how to change the configuration. Nothing in here was really very difficult. You're just going to hit scan, it's going to find the USB controllers, and you're going to select the devices and give them names. So this is where we name things that we're going to use in our programs. The next session in this room is going to talk a lot more on the programming side, so I won't really have time to get into that. But I wanted to talk about the debugging. Op modes are the new name for user programs, and it's just a program you can start and stop from the driver station. That's really all that it means. An op mode, really what I suggest doing is just take one of the existing ones, like the K9 teleop, copy it, make a new, and when you copy and paste it, it'll ask you for a new name, and then that'll be your new teleop program. And it'll have all of the boilerplate code that you need in there. But the only things we have to change are in the initialization method, we're going to set up our hardware, and this is where we use the names that we had in the configuration file and assign them the variables. And in the loop, we're going to access the gamepad, and we're going to set motor values. This was for the meetings, which was really simple. We also have the ability this year of sending information back to the driver station. They call that telemetry. So almost all of the example app modes show how to do that. The last kind of important thing to note is in order for your op mode to show up on the driver station, you have to do something called registering it. And there's one program called FTC Op Mode Register that you'll want to edit. And we actually deleted all the existing ones because they don't really run unless your robot's configured that way. And then just had the ones that are applicable to us. So then from our driver station, our list is a lot smaller. The one last thing I wanted to point out that kind of got us for a little while is when you first connect up the driver station to your joystick, the very first thing you'll want to do is hold down Start and A for joystick 1 and Start and B for joystick 2. And if you don't do that, everything will seem like it's working, you just won't get any joystick values. So when it's connected to the joystick and you move the joystick values or whatever, the little joystick icons in the top corners will light up to tell you if you're joystick user 1 or user 2. From there, the driver station itself is pretty self-explanatory once everything's paired. And we're kind of at the point for questions. Are there any quick questions on anything we've gone over today? Yes?
Will this presentation be on the FTC site?
I'm sure the presentations will be available. I don't know. Probably high-tech kids.
Yeah.
Okay? They kind of big gloss over a lot of stuff.
We'll also put it on lazybots.com.
And lazybots.com, yes.
Are we bringing our own joystick controllers to the competition?
Yes. Yeah, you will practice and play with the exact same equipment.
Do they have to use Logitech controllers?
That will be in the game manual. I think it did specify to use Logitech. It looks like it works with Xbox controllers too, but I think the game manual says Logitech. Yes. The NXT sensors are supported for right now until you hear otherwise. Port 5 on the expansion module has a code bug, so don't use it for sensors. Don't use it for anything. It doesn't send some. They'll probably fix it in the next SDK release, but there's a known bug on port 5. Everything else should work pretty easily. Any other questions? All right, we'll have fun this year. Oh, do you have one more?
Yeah, do you have a thought on how you guys can do version control for your teams
We're using GitHub. We use GitHub. We have an online Visual Studio account that then we set to use version GitHub as its TFS, and right in Android Studio it can connect up to the Visual Studio online Git server. So that's how we're doing it. Yeah.
Can I make a quick announcement? We also have, on October 3rd, there is another FTC workshop that's coming up that is going to be in the same location, and it's going to be an all-day session. So I have flyers right here, and we'll have them at both of the doors, so if you want to grab a flyer on your way out, that'd be great.
LazyBots will be here for that too.
Yep.
If you guys want to come up and take a look at these, we have a minion running on complete new platform and also one with the legacy module and our old motor controller.
And I think that's the end of our time for our presentation. And next is programming with Ponytail Classic. We'll be